quick response with limited capacity. In this part, we will consider a case of multiple products. And again, we will have two order opportunities. So there will be, long before the season, we will have a first order opportunity where we can order some of the products or some quantities. And then after a certain period of time, still before the season begins, we will observe pre-booking orders from retailers. So we're now operating, for example, a distribution center when we order products to hold them in the distribution center from which some retailers purchase their products and then they sell them, right? So after we observe those initial pre-book orders from retailers, we can submit our second order, and then we can receive both of them just before the season begins and the selling season is here, and then there are some leftover units. So in this example, there won't be any premium. The cost on the units in the second order will be the same as the cost for units in the first order. However, the second order opportunity will have a limited capacity. So this is a new thing, right? Limited capacity in the second order. And the limit, because you see, we actually have no way of telling exactly how much we will order here because it all depends on the observed demand. Instead of limiting this capacity directly, we will actually say, well, let's assume in the first order, we have to make a reasonably large orders in order to avoid potentially large quantities in the second order, right? So that basically, in order to avoid overusing capacity for this short reactive capacity, right, with short lead time, we will actually order a large enough quantity in the first order. So let's consider the example we have. We're going to have 10 products, right? They're in numbered 1 to 10 with different demand distributions, all assumed to be normal distributions with given mean and standard deviation. So here is the coefficient of variation calculated from the preceding two columns. We're also given the price at which we sell. This is a wholesale price at which we sell to the retailers, but we also have margin and discount, right? And this is a different way of providing us with the cost and salvage value. If the margin is 38%, then we know that if the price is 120, 38% of this 120 is our gross profit, and the remaining part, 62% in this case, is actually the cost. So we can calculate the cost as price times 1 minus margin, and we can calculate the salvage value similarly as price times 1 minus the amount of the discount. If we discount 65%, that means 35% of this is the salvage value. And now in this example, we will consider that our supplier requires that, right, in order to have this second order opportunity, the total number of units, total quantity for the products that we order in the first order opportunity, right, is at least 10,000 units. So we will be maybe ordering a subset of those products in the first order opportunity. Whatever the subset we choose, the number of units has to be at least 10,000, and this is indirectly trying to limit what we will order in the second order opportunity. So as before here, the question is, what should we order in the first order opportunity, which products and what quantities, in order to maximize the expected profit from all those 10 products. As before, we will make the assumption that the forecast of demand is perfect after we observe pre-book orders from retailers. Again, it is a strong assumption. Maybe the forecast doesn't become perfect. It just becomes much better quality, right? So much smaller standard deviation or coefficient of variation. Right? There is a big reduction in these parameters. However, in practice, it wouldn't become perfect, and because of this, the evaluation of practical cases would be more difficult. However, for our academic example and to see the impact, it will be much easier if we assume that this forecast is perfect after observing initial pre-book orders. So what we will do, the way we'll solve this is we basically will use the news vendor model to find optimal order quantity, expected profit, maximum profit, and mismatch cost for each product separately. We have 10 products. We will basically solve the news vendor model 10 times. Now, we will say that, right, if you decide to order units, maybe this should be called ordered, in the first order opportunity, earn expected profit, while units ordered in the second order opportunity, they earn maximum profit. Why is that? Because remember, in the second order opportunity, we have a perfect forecast. So we assume we will earn maximum profit. No longer there will be this mismatch cost. Mismatch cost becomes zero when the forecast is perfect. Right? So the idea will be to sort products, right? So we want to choose products for the first order opportunity, those products that give us a small mismatch cost. However, remember, we have to also accumulate the largest quantity possible in order to reach this 10,000 total quantity as quickly as possible. So actually, in this example, it isn't just sorting it from the smallest mismatch cost to the highest, but actually we will consider a ratio, mismatch cost to the quantity, in order to select the smallest subset of products that reach the quantity quickly, at the same time accumulating the smallest possible mismatch cost, right? And once we sort the products like this, we will just take products in that order and fill the first order opportunity, right? Until the total quantity is large enough, in this case, 10,000. So in our example, this is what we will get. So I have the same 10 products. I've basically replicated in each row of my Excel spreadsheet the news vendor model, and I calculated underage, overage cost, and calculated the optimal order quantity, profit maximizing order quantity. We can then have all the measures like expected lost sales, expected sales, and leftover. And then we can calculate expected profit for each of those products, right? This is expected profit. We can also calculate maximum profit as the news vendor model prescribes, and we can, of course, calculate the mismatch cost. So now if I have mismatch cost, I can divide mismatch cost by the quantity to obtain this ratio, right? So once I do this, right, I've basically evaluated all the products using the news vendor model separately. Now what I will do is I will sort products by this ratio from the smallest to the largest, right? So here is the result of sorting. So this is the same part, right? But now products are ordered 4, 5, 6, 3, 8, 1, 7, and so on, right? And you see that the mismatch cost per quantity is actually increasing. And now I will be like selecting these orders, right? So I will start with 1,514. That's not yet 10,000. I will add this, and you will see in the first order opportunity, if I take the first 6 products in this order, I will exceed 10,000 units. And right, and I'm going to assume either you order a product in the first or in the second order opportunity, right? So here we order the first 6 products in the first order opportunity, and these 4 we postpone. Why do we postpone them? Because the ratio, right? So they have high mismatch cost and relative to order quantity, relatively smaller quantity. Of course, I mean, this one has a very high mismatch cost and also very high quantity, but the ratio is actually still very large. So the mismatch cost is really much higher than compared to other values, right? So you see, this way we order in the first order opportunity these 6 products, these quantities. We don't know actually how much we order for the remaining products, because remember, we postpone the order until we know the demand better. And when we know the demand better, we will actually choose order quantities subject to the knowledge of the new updated demand for those products, right? But the important assumption is that for those 6 products, we will receive something like an expected profit, right? Because we're just using our news vendor model. However, postponing those 4 products, we shouldn't expect this value of profit, expected profit. We should expect maximum profit, right? So so overall, the expected profit with 2 orders will be will give us these values, right? These being the previous expected profits, and these being the maximum profits, right? Because of those, we are assuming that demand will be perfectly forecasted by now. And in mismatch costs, we will have the same mismatch costs for those products with two orders because we order them as before with a single order. But for those four products, the mismatch cost will be reduced to zero, right? Where we will have a perfect forecast. So what I want you to see is now a comparison between those values, right? Before with one order opportunity, we have 762 $1,000 of expected profit. It goes up to $955,000 of expected profit. Or if you like, we can look at the mismatch cost, which was 291, almost $292,000, and now it drops to 98, almost $99,000. So almost threefold decrease. So to summarize, in this case, if we have limited capacity and we can only produce in the second order opportunity limited reactive capacity, and we can produce using this reactive capacity only some of the products, we can still significantly improve our profit. We can, in this example, the expected profit increased by 25%. And if you want to look at the mismatch cost decreased by about 66%, all thanks to limited reactive capacity that was priced with no premium but had a maximum limit on how much can be produced in the second order opportunity.